Okay, today we're going to run through the answers to paper 1 from June 2019 for the foundation paper. Starting off nice and easy, we know that 1 hour equals 60 minutes. Therefore, 180 minutes, my multiplier is to multiply by 3. Therefore, there are 3 hours in 180 minutes. To go from a decimal into a percentage on this question, I need to be multiplying by 100. Therefore, 0.73 multiplied by 100 is 73%. In this question, I need to remember BIDMAS, or as I like to use BIRDMAS, like so. Please remember when they're on the same level, here and here and here, it means it's whatever comes first. In this question, I've got brackets. The brackets I'm going to work out first is 8. I'm going to bring down the multiplied by 10, and I'm therefore going to get 80. A prime number between 20 and 30. The easiest way to do this is to write down all the numbers first of all between 20 and 30. Like so. I would then cross out all the even numbers, so all the multiples of 2. I would cross out all the multiples of 3. 24 has already been crossed out. 27. All the multiples of 5, just 25 left now. And then all the multiples of 7, of which I've already crossed out the 21 and the 28. So I'm left with 23 and 29. I only need one of these, just ease the one onto my answer signs, absolutely fine. Find the number that's exactly halfway between 7 and 15. This is the same as a midpoint question, so I'm just adding together and then dividing by 2. Well, 7 plus 15 is 22, divided by 2 is going to be 11. The next one. Harry is planning a holiday for 4 people for 7 days. Here are the costs of the holiday for each person. The travel is £150 per person. The hotel is £50 for each day. Spending money, £250. And we need to work out the total cost of the holiday for 4 people for 7 days. Okay, so we know that this is for each person. I'm first of all going to deal with this bit here, the each day part. So I know that 50 multiplied by 7 is £350 hotel per person. I'm then going to work out the total cost for one person. To work out the total cost of one person, I'm going to do the travel plus the hotel plus the spending money. I'm going to do my rough working out on the side over here. So for one person, it is going to cost £750 to go on a holiday for 7 days. We want all 4 people, so for 4 people, I would then do 4 multiplied by £750. Again, rough working out is going to go on the side. And you should get £3,000. Okay, nice and easy. Question 7. In Adam's garden, the flowers are only red, white, yellow, or blue. The chart shows the number of red flowers, number of white flowers, and the number of yellow flowers. The total number of flowers is 30. Work out the number of blue flowers. I'm going to start, just by writing out. Oh, get rid of that. I'm going to start just by writing out what I know. So I'm going to set it up as a table, is normally the easiest way to do it. So I've got red, white, yellow, and blue. And I've got my total column like so. Well, the red ones, there are 8 red ones. The white ones, there are 10. Yellow, there are 5. I don't know how many blue, that's what I'm looking for. But in total, I know that there are 30. So I can do 30, take away my red ones, plus my white ones, plus my yellow ones, which is 30, take away 8, 18, 23. Therefore, 7 blue ones. The mode is the most common, or a better way to think about it is the highest frequency. So I can look at my table that I've made up here, and I can just pick the one that's got the highest frequency in it, which is going to be white. Question 8, write the following fractions in order of size. Start with the smallest fraction. If I'm going to compare fractions, I need to have the same denominator. So I want a lowest common multiple of 3, 4, 12, and 2. The lowest common multiple of 3, 4, 12, and 2 is 12. If you didn't know that, then the best thing to do is to write down your times tables down the side for all of those numbers. I'm not going to write down the 2s because you'll be able to spot the 2s because they're just even numbers. And it is the smallest number in all of those lists. So we're going to make all of our fractions now out of 12. My first fraction currently has a denominator of 3. To make it a denominator of 12, I need to multiply by 4. My second fraction currently has a denominator of 4. To make it into 12, I need to multiply by 3. Therefore, I get a numerator of 9. Same again, I'm multiplying by 3 to get a multiple of 3. My next one already has a denominator of 12, so I could, if I wanted to, multiply by 1, but I don't really need to. And my last fraction, I multiply by 6, again to get a denominator of 12. I then just need to order these numerators. Well, my smallest numerator is 3 over 12, which was 1 over 4. My second is 4 over 12, which was 1 over 3. 3, 4, 6 is my next one, which was 1 over 2. 7, which was 7 over 12. And then 9 over 12, which was 3 over 4. Okay. Ruth left her home at 9 a.m. and walked to the library. She got to the library at 10:30 a.m. and she walked at a speed of 4 miles per hour. Work out the distance Ruth walked. So first of all, it's a speed distance time question. I'm going to start by writing out what I know and getting my formula ready. I know that she leaves her home at 9 a.m. and gets there at 10:30. Therefore, it takes her 1 hour, 30 minutes. And I know that she walks at a speed as 4 miles per hour. Before I can do anything with this, I need to make sure that this unit here, my hours unit and my speed, matches my time unit. Currently it doesn't, because currently I've got hours and I've got minutes. Some of you might just be able to look at that and tell me that it's 1.5. If you didn't know, I recommend first of all turning it into minutes, like so, and then dividing by 60 to work it out as a decimal. Now remember, when we do 90 divided by 60, let's write this up here so you can see it. 90 divided by 60, I can cancel my zeros in pairs, and I'm left with 9 divided by 6. I can then go into a bus stop to get 1.5, so it's 1.5 hours. I now know my formula of speed equals distance over time. I'm now going to put numbers in the right places. 4 equals d over 1.5. To solve this equation, I'm going to multiply by the denominator. Rough working out again can go on the side if I need it. If you can do it in your head, not a problem. And I'm going to get distance is 6 miles. Ruth got to the library at 10:30 a.m. and she stays at the library for 50 minutes. She then walked home. She took 1 1/4 hours to walk home. When did she get home? So she was at the library at 10:30 a.m. She then stays at the library for 50 minutes. So I'm going to work out, first of all, I know this is going to go past 11 a.m. So I'm going to work out how many minutes is it to get to 11 a.m. Well, that's 30. I know I need to do 50 in my first instance. I'm going to add my second 20 to make sure I've got a total of 50 down the bottom. And I've got 11:20 a.m. So at 11:20 a.m., she leaves the library. Okay. She then walks home, which takes an hour and a quarter. Now, so I've got 1 hour, and I also need to work out this quarter here. To turn it into minutes, if I multiply by 60, remember I'm going to put an over 1 to make my multiplying a little bit easier. 1 times 60 is 60, 4 times 1 is 4. I can then work out 60 divided by 4 on the side. So it's 1 hour and 15 minutes. Okay. I'm going to add on my hour first, because it's easier. If I add on 1 hour, I'm going to go to 12:20 p.m. because I've gone past midday. I'm going to add my 15 minutes. I'm going to get to 12:35 p.m. You have to have the p.m. on your answer. Squeeze it in there. You have to have the p.m. on your answer or you end up losing a mark. Next one, t plus t plus t equals 12. Well, that means that 3t is equal to 12. One-step equation, divide both sides by 3. T equals 4. X minus 2 is equal to 6. My inverse of subtract 2 is going to be to add 2 to both sides. X equals 8. Two-step equation this time. I'm going to start by moving my constant away from my variable. Here's my constant. Here's my variable. I take 2 from both sides. 6w therefore equals 18. Divide both sides by my coefficient. Therefore w equals 3. Question 11 is a nice easy one. It's a multiplication question. Eight multiplied by 4 is 32. Carry the 3. 8 times by 7 is 56. Add the 3 is 59. Placeholder. 5 times 4 is 20. 5 times 7 is 35. Add 2 is 37. Add 2. 9, 12, and therefore 3. So 3, 2, 9, 2. AB and BC are perpendicular lines. I'm going to annotate my question here, which means meet at 90 degrees. Work out the value of x. Well, therefore, I know that all these angles inside here add up to 90 degrees. So I can say that 25 plus x plus 25 equals 90. I can collect like terms, and I can solve. My next one says, RF and TU are parallel lines. PQ is a straight line. An angle of 125 degrees is shown on the diagram. Write down the letter of one other angle the size is 125 degrees. Write down a reason for your answer. I'm going to go straight in with the easy one here, which is B is equal to 125 degrees. And that's because vertically opposite angles are equal. If I get an X shape like this, then these two angles here will be the same. Similarly, these two angles here will be the same. So I'm going to use B equals 125 degrees, and I have to write vertically opposite angles are equal. There are other options that you could have had, but that's the easiest one to spot. Explain why A plus B plus C is equal to 125 degrees. Now, sorry, 235 degrees. Now, all of these angles here meet at a point. So I can say that A plus B plus C plus 125 equals 360 degrees. And over here, I'm going to write angles around a point, sum to 360. Make sure your language is correct, because that's what the mark scheme wants you to write. And I can make this that I've written here look like this by removing the 125 from both sides. So I'd write A plus B plus C equals 235. Question 13. The length of a line is x centimetres. Write down an expression in terms of m for the length of the line in millimetres. Well, if we go to centimetres, 1 centimetre is equal to 10 millimetres. I know this by looking at my ruler. Therefore, if I was going from centimetres into millimetres, I would multiply by 10, and vice versa. I would divide by 10. This time, I've got x centimetres over here. So I'm going from centimetres into millimetres, and I've written down here that I'm going to multiply by 10. So x multiplied by 10, 10x. A fifth of 70, well, of means time, so 1 over 5 multiplied by 70. On a non-calculated paper, I'm going to make my life easier by putting in an invisible denominator of 1. I then just need to multiply my numerators and multiply my denominators, and I can just do my basic plus stuff on the side out of the way. Should get 14. Fiona has to work out the exact value of 48 divided by 1 over 2. She writes 48 divided by 1 over 2 equals 24. Fiona's reason is there are 2 halves in 1, so there will be 24 halves in 48. Explain what's wrong with Fiona's reason. Whenever you get explain what's wrong with someone's answer on a exam paper, I recommend working out for yourself on the side. So when I'm working with fractions and I'm divided, I need to remember that I'm going to multiply by the reciprocal. Again, invisible denominators to help me. So here, I can just say the answer is 96. And then I'm going to write Fiona hasn't used a reciprocal. Okay, question number 15. Write down the value of the square root of 64. Well, this means I need to know my square numbers. If you need to, you could write out all your square numbers if you've got time, etc. And you will eventually get to 8 squared equals 8 times 8, which is 64. Therefore, my square root is 4. The value of 5 cubed, please remember this means 5 multiplied by 5 multiplied by 5. Well, 5 times 5 is 25. Multiplied by 5 again is 125. Expand, we know brackets means times, so I'm multiplying everything inside my bracket by what's outside. Onto my answer line. 10m minus 15, because we've done 5 times 2m is 10m, and 5 multiplied by minus 3 is negative 15. Factorise is the opposite of expanding, so I need my highest common factor, first of all, of my 3 and my 12, which is going to be 3. There is no variable shared between my two terms, therefore I'm going to open my bracket. To work out what goes inside my bracket, I divide both of my terms by 3. So I get n, or 1n is also fine, plus 4. Question 17. Stuart throws a biased coin. Biased just means unfair. And he throws a biased coin 10 times. He gets 7 tails. Maxine throws the same coin 50 times and she gets 30 tails. Prasha is going to throw the coin once. Whose results will give the better estimate for the probability that she will get tails, Stuart's or Maxine's? You must give a reason for your answer. Now, these questions are really straightforward. The answer is Maxine. And that's because she has conducted more trials. She's done it more times. She's more trials. That's quite scientific. If she's done it 50 times, he's only done 10. So hers is more reliable. You can just write she's done it more times. That's absolutely fine. Use Stuart's and Maxine's results to work out an estimate of the probability that Prasha will get tails. So I know that Stuart, he got 7 tails out of 10. And I know that Maxine, she got 30 tails out of 50 times. Okay, so in total, they've both thrown the coin together 60 times. And between the two of them, they've got 7 and 30, they've got 37. My estimate for the probability would be 37 over 60. Question 18. The diagram shows a rectangular garden path, which measures 120 centimetres by 600 centimetres. Wazim is going to cover the path, I'm going to underline that word, cover the path with paving stone. Each paving stone is a square of side 30 centimetres. Each paving stone costs £2.50. Wazim, has got £220 to spend on paving stones. Show that he has enough money to buy all the paving stones he needs. Right. First of all, cover is my clue. That tells me it's an area question. So I'm looking at this shape here and I know that I'm going to need my formula for the area of a rectangle, which I'm going to write down here. Each paving stone is a square of side 30 centimetres. I'm going to draw myself a picture. I know that squares have got the same lengths here and here, so I'm going to write those on. And I also know here that 1 paving stone equals £2.50. Show that he's got enough money to buy all he needs. The first thing I'm going to do is work out how much area am I going to try and cover. So I've got area is equal to 600 multiplied by 120. On a non-calculated paper, I'm going to do 6 multiplied by 12, which is 72. And I've ignored 1, 2, 3 zeros. My units are really important in this question, so it's centimetres squared. So I know the total area that I need to cover is 72,000 centimetres squared. And I need to work out how much area does one of these paving stones cost. Well, the area of a square is area equals length squared, which is 30 squared, which I'm going to write out now is 30 multiplied by 30. Same again. I'm going to do 3 times 3 is 9. I've ignored 1, 2 zeros. My units are centimetres squared. So I now know that 1 paving stone covers an area of 900 centimetres squared. I also know that I need to cover an area of 72,000. So I'm going to put that underneath in my ratio, matching up my units. And I'm going to work out a multiplier. Some of you, again, might be able to spot what that multiplier is. In case you don't know, we're going to do this number here divided by this number. Whoops. Now, I'm going to set that up as a fraction. Again, all my rough working out's over here on the side. My zeros I'm going to cancel in pairs until I'm left with 720 divided by 9. Well, 720 divided by 9, 9s into 7 goes 0, carry the 7, 9s into 72 go 8, 9s into 0 goes 0. So I've got a multiplier by 80. Therefore, I know I'm going to need 80 paving stones. I still have to work out the cost, aren't I? So 1 paving stone, we know, right back up here again, costs £2.50. I've now worked out I need to buy 80 of them. So I'm going to multiply by 80. Multiply by 80. Rough working out on the sides. rough working out on the sides. And first we're going to work out 25 multiplied by 8, sorry, just ignoring all the decimal place for just a moment. 8 times 5 is 40, 8 times 2 is 16, and 4 is 200 there. Now I've changed my place value in this question by 1 to get to 25, and this one by 1 to make 80. So actually don't need to alter that at all. It's going to be £200. In case you're not sure how that's kind of worked, then I recommend doing it with the decimal points and putting those back in at the end. But if you understand how to jump from here to here, it makes your life a lot easier. My question is to show that question, so I don't really need to do anything. It says that Waz's got £220, show that he's got enough. Just to show an examiner I know what I'm talking about, I'm going to say that 220 is more than, oops, not one word, more than £200. Okay, alternatively, you could have written 220 more than 200. Question 19, fractions. Work out 2 over 3 multiply, subtract 1 over 5. When I'm adding and subtracting fractions, I need the same denominator. My lowest common multiple of 3 and 5 is going to be 15. I'm going to set both my fractions up like so. To make my first fraction to 15, my denominator is currently 3. I need to multiply it by 5. My numerator is 10. To make my second fraction to 15, I need to multiply it by 3. Then it's nice and easy. I get mark 1 for getting the same denominator. 10 subtract 3 is 7 over 15. Multiplying fractions is the easy one. In this question, however, I've been asked to give an answer as a fraction in its simplest form. So I need to watch out for that with my answer in a moment. 2 times 3 is 6. 3 times 4 is 12. To simplify this fraction, I need my highest common factor of 6 and 12, which is divide both by 6. You could divide by 2, again, divide by 2 again, but it's a little bit longer, and you're going to get 1 over 2. Question 20. Here are two squares A and B. The length of the side of square A is 50% of the length of the square of side B. Express the area, keyword, of the shaded region of A as a percentage of the area of square B. First of all, I'm going to give square B a variable. I'm going to call it x. I know that square A is 50%. I'm going to work in decimals, so 50% is 0.5. 50% of the side length of square B. So I can say that this one over here is 0.5x. Okay, it's half the size, it's 50%. It says the area of the shaded region, so the shaded region is here, it's going to be half of my square over here, as a percentage of the area of square B. Now we know it's an area question and we know they're both squares. So I know I'm going to be area equals length squared. Let's do A and B. Well, the area of square A is going to be area is equal to 0.5 squared, it follows, x squared, which remember is 0.5x multiplied by 0.5x, or 0.5 times 0.5 is 0.25, and x times x is x squared. My second one is a little bit easier, it's just x squared. I could write out area therefore as x times x, but I'm just going to get back to area as x squared, so I'm going to leave it as it is. Now, this is the area of my entire square, this 0.25x squared. I just want the shaded region. Well, my shaded region is half of that, so I'm going to do 0.25x squared divided by 2. 0.25 divided by 2, if you need to, again, you can do it on the side here. 1, 2, remainder 1 is 0.125. Okay. To express as a percentage, I first need to express it as a fraction. I'm running out of room here. So I'm going to express it as a fraction first of all. It's always going to set it up in the same way. It's going to show you the numerator, the first bit here. And then it says percentage of, and this part here is going to be your denominator. My numerator, therefore, is 0.125x squared. My denominator is x squared. That's as a fraction. To go from a fraction into a percentage, I'm going to have to multiply by 100. My x squareds are going to cancel in pairs, and I'm left with 0.125 multiplied by 100, and I get 12.5%. Question 21. There are 40 students in a class. Each student walks to school or cycles or gets the bus to school. There are 22 girls in the class. 9 of the girls walk to school. 7 of the boys cycle to school. 6 of the 10 students who get the bus to school are boys. Find the number of these students who walk to school. The easiest way to set this up is looking at a frequency tree. So I'm going to start off with 40. You can draw this frequency more than one way. It's easier most of the time just to start with boys and girls, so to start off with 2 branches rather than 3. Try and write quite large because people always get them squished in and can't read them. And then my categories are walking, they cycle, or they get the bus. Okay, then we can start putting numbers in. We know there are 22 girls, and it goes. I've used that bit. 9 of the girls walk to school, or girls and walking is here. 7 of the boys cycle to school. 7 goes over there. 6 of the 10 students who get the bus to school are boys. This one's a little bit tricky. 6 of the 10 students who get the bus are boys. So I know there are 6 in here, but I know my total for the bus needs to be 10. When I've put all the information into my diagram, I can then just start working out gaps. Now, I know that these 2 branches here need to add up to give my previous bubble, if you like. So for this box here, I'm going to work out 40, take away 22, which is going to give me 18. Again, if I look down here at the minute, I can't work out these 3 using the 22 because I've got too many gaps. I can, however, just work out this part here. So I know that these 2 bubbles are going to add up to give me 10. I know one is 6, therefore here is 4. And then with my last sections here, I've now got 1 bubble missing. I know that these 3 here are going to have to add up to 22. So I can do 22, take away 9 and 4, which is 22 minus 13, which I believe is 9. The same again up here. I know these 3 bubbles are going to add up to give me 18. So I can do 18 take away 7 plus 6, which is 18 take away 13, which is 5. My question says, work out the number of these students who walk to school. Well, 5 boys walk to school and 9 girls. Therefore, 14. Question 22. There are only blue cubes, red cubes, and yellow cubes in a box. The table shows the probability of taking at random a cube from the box. It shows that blue is 0.2. The number of red cubes in the box is the same as the number of yellow cubes. I'm therefore going to label these as X and X to show that I know that they are the same size. I'm also going to put at the end of my table equals 1. We know that when we have probabilities, they're all going to have to add up to 1. I can therefore say 0.2 plus x equals 1. 0.2 plus 2x equals 1. And I can solve my 2-step equation. Some of you may be sitting there and thinking, I can do that in my head, I don't need to write that down. When it gets more difficult, you won't always be able to do it in your head. So I highly recommend forming and solving equations. 0.4 and 0.4. There are 12 blue cubes in the box. Work out the total number of cubes in the box. Once again, I'm going to use a ratio table. So blue, red, yellow, and a total. And I'm going to put 0.2, 0.4, 0.4, and 1. There are 12 blue cubes in the box. I'm going to put 12 into my correct category, which is blue. And I'm going to work out a multiplier again. To work out the multiplier, I'm doing 12 divided by 0.2. Worth working out on the side, setting it up as a fraction. When I'm dividing and I've got my denominator with a decimal, I need to multiply by a power of 10 so that this is an integer. There is 1 decimal place in my denominator. Therefore, I'm going to multiply both by 10 to get rid of that decimal place. I'm going to get 120 over 2. That makes it really easy now. 120 divided by 2 is 60. So I know my multiplier is to multiply everything by 60. I've been asked to work out the total number of cubes in the box, which is 1 times 60, which is 60. I could work out these if I wanted to, but I don't really need to. But just in case you wanted to, it's 24 and 24. Question number 23. Leon needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much as flour as sugar, 2 times as much butter as sugar, and she's going to make 60 biscuits. Work out how much flour she needs. So first of all, here, really easy first marks. I'm going to say I need 3 times as much flour as sugar. So I'm going to do 3 times the amount of sugar, which is 150 grams. Okay, and that one there, I'm just going to annotate so I know what I'm doing, is the flour. I also know for the butter, she needs 2 times the amount of sugar, so 2 times 50 grams is 100 grams. Once again, I'm going to annotate that with butter so I don't forget what I'm doing. I know that we only care about the flour. So I know to make 15 biscuits, I need 150 grams of flour. If I want to make out 60 biscuits, I just need to work out a multiplier. To work out a multiplier, here it's 60 divided by 15, which is multiplied by 4, multiplied by 4. Therefore, if you need to do rough working out on the side, you can, but you will get to 600 grams. Okay. Dion has got to buy all the butter that she needs to make 60 biscuits. She buys the butter in 250 grams packs. How many packs of batter does Dion need to buy? So first of all, I know already that 15 biscuits, just ignore that, 15 biscuits equals 100 grams of butter. I know that we're making 60 biscuits. I've already worked out before that my multiplier is going to be to multiply by 4. So I'll multiply by 4. I need 400 grams. They're sold in 250 gram packs, so one pack would be 250 grams. If I went and bought 2 packs, I'd get 500 grams. And oh look, I've already got enough. I need 2 packs of butter. I can't have 1 point something of butter or whatever it may be, because I can't go into a shop and cut a block of butter in half. I have to buy the whole packet. Question 24, the highest common factor of 72 and 90. I'm going to start off with my factor trees. Any factor pairs that you've used to get to this point is absolutely fine, as long as your circled primes are the same. 90. Okay, I'm going to write them out as products. I'm not going to use index form. And then 90, 2, 3. The best way to work out a highest common factor or a lowest common multiple is to use a Venn diagram. That's a bit shaky. There's 72 and 90. Starting off with my intersection. Numbers in both lists, there's a 2, and I'm going to cross it off. There's a 3 in both lists, and I'm going to cross it off. Another 3. Left over for 72, there's a 2 and a 2. Left over for 90, there's a 5. If I were asked to work out the lowest common multiple, I'd multiply everything inside that Venn diagram. But the highest common factor, I'm just going to multiply the numbers in the intersection. So 2 times 3 times 3. 2 times 3 is 6, times by 3 is 18. Question 25. The diagram shows the plan. So the plan is when you're looking down on a shape. The front elevation, the side elevation are a solid shape, drawn on a centimetre grid. In the space below, draw a sketch of the solid shape. Give the dimensions just means measurements, of the solids on your sketch. So when I look down on the shape, I see a circle. But if I look directly from either side, I end up seeing a rectangle. That means I'm going to see a cylinder. So you're going to draw something that looks like this. It doesn't matter if you're not very good at drawing. Now the dimensions, well, the width of this, or I should say the diameter of this here, is going to be 4 centimetres. And the overall height of my cylinder is going to be 1, 2, 3, 4, 5 centimetres. Okay, in this question you get 1 mark for drawing a cylinder and your 2nd mark for adding on the dimensions. Question 26. Shape A can be transformed to shape B by a reflection in the x-axis followed by translation C, D. Write down the value of C and the value of D. The first thing we're going to do is just do as it says. I'm going to reflect in the x-axis, starting with shape A. Well, my x-axis is here. When I reflect in the x-axis, it means that my shape is going to be equidistant from that line. So I'm going to do it 1 point at a time. So my first vertex I can see is 2 boxes away from my line of reflection. So I count 1, 2, the other side, and I put my mark on. The same again. My second vertex is 1, 2 away from the line of reflection. So 1, 2 again. My last one is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. I'd get my first mark just for reflecting my triangle into the correct position. Okay. I've then been told that it's been there's been a translation. Translation means moved across the page with the vector C and then D. So I'm going to work out how has this shape here ended up on shape B. So I'm going to pick a vertex. I'm going to pick this one. And I'm going to circle the corresponding vertex on my final shape. The reason I picked that one is because the right angle is the easiest one to spot. Just a reminder about how vectors work. Your top number tells you how you're moving left and right, with right being your positive and left being your negative. And your bottom number here tells you up and down, negative, positive. So I need to move 1, 2, 3, 4, 5, 6 I think I've counted that correctly, 6 to the left, and I need to move 1 down. If I'm moving 6 to the left, my left hand is going to be a negative, so my vector would be negative 6. If I'm moving 1 down, again down is going to be negative, negative 1. Therefore C is negative 6, and D is negative 1. Question 27. A shop sells packs of black pens, packs of red pens, and packs of green pens. There are 2 pens in each pack of black pens, and there are 5 pens in each pack of red pens, 6 pens in each pack of green pens. On Monday, the number of black pens sold, the number of packs of black pens sold, the number of packs of red pens sold, the number of packs of green pens sold was 73 to 4. A total of 212 pens were sold. Work out the number of green pens. The most common mistake in this question is that people try and put this number here, so 212, they try and put 212 into this ratio. We can't do that. The reason we can't do that is because I've got 212 pens, and this ratio is talking about the packs. Okay, so let's start off with writing down what I know about the packs of pens. So again, I've got black ones, I've got red ones, and I've got green ones. That one is 7, 3, 4. But that is only about, it should be down here, that is only about the packs of pens. If I want a ratio of my actual pens, then I'm going to need to make sure that I know how many pens are in each black box. So I've multiplied my first one by 2, because there are 2 pens in each black box. So they've sold 14 black pens in that ratio. The red pens, there are 5 in each packet, therefore there are 15 pens that have been sold. The green pens, there are 6 in each packet, therefore there are 24 pens that have been sold. So my ratio for my pens is 14 to 15 to 24. I could then work out myself a total column. Well, 14 plus 15 plus 24, I'm going to work out on the side. It's 53. My total number of pens needs to be 212. So to work out a multiplier, I can do 212 divided by 53. If you don't know your 53 times tables, I'd let you off. But what I would do to help you is I'd write down, just start listing them. So 53, 106, add another 53 would be 159. Add another 53 would be 212. I hope. Yep, 212. Therefore, 1, 2, 3, 4. So we're multiplying by 4. When I multiply all of my pen ratio by 4, 14 times by 4 is something. It's 56. I think that's wrong. No, it's not wrong. 56. 15 multiplied by 4 is 60, and then 24 multiplied by 4. Again, I can do all my rough working on the side out of the way. 2 times 4 is 8. It's 96. My answer line is how many green pens were sold. Well, green, and then pens. Green pens is going to be 96. Question 28. Here are 2 rectangles. QR equals 10 centimetres. Oh dear. QR equals 10 centimetres. Let's write that on over here. BC, so here's BC, equals PQ. Here's PQ. Remember, when we're told 2 things are equal, we want to label them with the same variable. The perimeter of ABCD equals 26 centimetres. I'm going to write that down underneath. The area of PQRS, I'm going to write that one inside, is 45 centimetres squared. Find the length of AB. Now, I've been told it's an area and a perimeter question. If I look at this rectangle over here, I can't really do anything with that perimeter knowledge because I don't know any of the side lengths. But this question over here, I've got the area and I've got one of the lengths, I'm missing a width. I could therefore use my formula for the area of a rectangle to then work out the missing width. Again, numbers in right places. So 45 is equal to 10 multiplied by x. I can solve by dividing both sides by 10. Therefore, x is 4.5. Once I know x is 4.5, I therefore know x is 4.5 over here. In a rectangle, please remember that the parallel lengths are equal in size, so this is also 4.5. In the same way, I could then label this side length and this side length with the same variable. I'm going to use y. Now I know that all these 4 side lengths here add up to give me 26. I can say y, plus 4.5 plus y plus 4.5 equals 26. I can collect like terms. 2y plus 9 equals 26. And once again, I've got a 2-step equation to solve. At this point, you could just write 17 over 2, or you could write 18.5. Sorry, 8.5 is completely up to you, doesn't really matter. You'll get the answer mark either way. Question 29. Here is the graph of y equals x squared minus 2x minus 3. Write down the coordinates of the turning point of the graph y equals x squared minus 2x minus 3. Turning point is exactly what it says on the tin. It's where does the graph turn. Your graph turns, it comes all the way down, 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 and it goes back up. There's my turning point. The coordinates of my turning point, remember we're going to go x and then y, is 1, negative 4. Use the graph to find the roots of the equation x squared minus 2x minus 3 equals 0. This part here tells me when it says equals 0, what I'm interested in is the x-axis. If it said equals to a number, I'd have to draw a line, but the roots of the equation when it's equal to 0 just means where does my graph cross the x-axis? Oh, well, it crosses at x equals minus 1 and at x equals 3. Make sure you write x equals and x equals and not just 1, 3, because you won't get the mark for that one.